complex number -2 minus 2 root 3I in the polar form r CIS theta, where theta is an angle between 0 and 2 pi. So r CIS theta is shorthand for r times the cosine of theta plus I times r times the sine of theta. R is the polar radius and theta is the polar angle. So our complex number has a real part of -2 and an imaginary part of -2 root 3. And so the complex number lies in the third quadrant. The polar radius is the distance to the origin, and the polar angle is measured from the positive real axis. So first, the polar radius, r, is the same as the modulus of the complex number, which is the square root of the sum of the squares of the real and imaginary parts. So the square of the real part plus the square of the imaginary part, and that gives us 4 plus 4 times 3, and the square root of 16 is 4. So our polar radius is 4. Our complex number is 4 units from the origin. Now for theta, we'll use the tangent function. The tangent of theta is y over x. That's the imaginary part divided by the real part. -2 root 3, that's our y, the imaginary part, and -2 is the real part, the x. And that ratio simplifies to square root of 3. So the tangent of theta is the square root of 3, and that means that if we do the inverse tangent of the square root of 3, we'll get an angle in the first quadrant corresponding to 60 degrees, or in radians, pi over 3. That's not the angle we like because our complex number is in the third quadrant, so our angle is a modification of this. It's pi over 3 plus 180 degrees, or pi radians, which is 4 pi over 3. So these are the polar components. R is 4 and theta is 4 pi over 3. And so we can write the complex number as -2 minus 2 root 3I equals 4 CIS 4 pi over 3. The radius and the angle.